Hello, so continuing on this Leetcode biweekly contest 16, the second problem was sum of mutated array closest to target. And so the problem is medium problem with 1300 sum of mutated array closest to target. So what the problem says is that given an array and the target value, we want to return the integer value such that when we change all the integers larger than that value in the given array to be equal to value, the sum of the array gets as close as possible in absolute difference to the value target, which means basically as close as possible to it, and can be smaller, also can be bigger, since they said in absolute difference. And in case of a tie, we want to return just the smallest one, the smallest value that is. And so the smallest difference in terms of the sum, and we're going to return the smallest value if there is a tie. And the answer doesn't have to be in the array, right? So for example, in this example it is, but so 493, the target is 10. So the closest sum we can get to 10 is by replacing anything bigger than 3, which means we'll replace 4 and 9, and we'll get 9 as the sum, which is very close, which is the closest thing to 10 that we can do. And then if we do this one, and the target sum is 5, then the right thing to do is just keep it as it is and return and just replace anything bigger than 5, which means basically just keep it as it is and get the value, the exact value target, which is the best thing we can do. A similar thing for the last example. If you look here, the length of the array is 10 to the power 4, so a no-Venn algorithm linear search would be fine, but we can't do a double loop or something like that. So let's see how we can solve this problem. Okay, so let's see how we can solve this problem. So let's take an example here. So let's say we have this example: 4, 9, 3, 2, 5, 1. Right? So one idea we can think about is, okay, so one observation first. The first observation we can have is, well, if we try basically after max, like if after the max of the array, or actually from max array, if we set value to be max array, then that would mean that we won't ever need. So if we set value to equal to max array, that means nothing will change in the array, right? Nothing will change in the array because let's say, for example, if I take 9, let's say if I take the value to be equal to 9, well, I need to change any value in the array that is bigger than 9, but since it's the max, I will change nothing. Now if I take 10, I will change also nothing. If I take 11, I will change also nothing. But sometimes the max is the solution because the array sum is the exact value. Like in the problem statement, the second example was 2, 3, 5 and target equal to 10. So taking exactly value to be 5 so that we don't change anything will give us 7 plus, will give us 5 plus 5, which is 10, right? And the problem says if we have multiple solutions like that are very close, let's say 6 gets us the same thing, 7, we should take the minimum, and the minimum is always the max, right? So that's one observation we know, right? So one thing we can say, okay, let's just try all of them. Let's try from 0 to max array and pick the max, right? Just brute force that. So try all from 0 to max array. Basically as value. So try value to be 0 and see if that gives you something close to target. And see basically if that gets you something closer than the previous value, set it, otherwise continue and take value equal to 1 all the way until value equal to 9. And if we do that here, we will find out that the solution is value to be equal to 3. But we will go all the way until max array, and that's fine. The only thing is that we since the array length can be, the problem says that the array length can be equal to 10 to the power of 4 to the power of 4. So that would mean here that we don't want to do O of n square algorithm. We don't want to do that. And so ideally we should have O of n, right? But if we try every one of them and every time we compute the sum in that case, right, that would be O of max array multiplied by n, right? That doesn't look like, since also the array values range between, the problem says that the array's value range between 1 and 10 to the power of 5, so we can end up with something that is 10 to the power of 5 multiplied by 10 to the power of 4. So that's not very good, right? So we will need to kind of make this a little bit better. So the way we can do that is, okay, let's just try sorting, right? So if we sort the array, what will happen? So if we sort the array, we'll end up with something like 4, 9, 3, 2, 5, 1, right? So if we sort the array like this, we will, no, not like this. So sorting that array won't give us that. So sorting that array would give it would give us 1, 2, 3, 2, 5, 1, right? Man, sorry. 2, 3, 4, 5, 9, right? So if we sort the array and then try values from 0 to max, which is to 9, so we will keep, so what we need is keep track of, what we need is compute the sum, right? And the sum will be basically equal to all the values smaller than, all the values in the array smaller than value, plus all those that got replaced with value, right? So let's call values all the values that won't get replaced by value because they are smaller. Let's call these left sum. And so, and then the rest that will get replaced because it's bigger than values, that would be just the array of, it would be basically the sum of value, right, for all a bigger than value, such a is in the array, right, for a in, yeah, right? So what that would mean is that we would just take the left sum. So here in this example, let's take a couple of values. So for value equal to 0 first, we would have, so let's just try a couple of examples. So for value equal to 0, we would have, well, nothing is smaller than 0, right? So everything else is left sum. So it's the sum of the entire array. So it's let me compute this. So it's 1 plus 2, which is 3, 6, 10, 15, and then we would have 24, right? So sum would be 24. So actually the sum, it won't be 24. So basically for 0, we will check all the elements in the array. The left, let me define maybe left sum in a more clear way. So left sum is all array values smaller than, let's call this here t, so that we don't get it confused. So here t is the value that we are trying to find. And so all the array value less than t, basically sum of all array values less than t, right? And so here nothing is less than 0, and so the left sum would be 0, right? So here left sum would be 0, and the right sum, which means replace everything in the array with 0, And so that would be meaning replace everything else. So we'll keep track of where we stop it. And here, since we stop it at I equal to 0 because we didn't change anything, right? So the right sum, let's call it, would be, which is the right sum of 0, would be replacing everything with 0. So basically it would be array I for I in the range. So it would be array I would be replaced with 0. So it would be the sum of zeros for the entire portion of the array on the right, which essentially means the length of the array. So the range would be length of the array minus I, right? So for all of them, right? And so that would give us left sum, the entire sum to be 0. Well, we will compare that with the, we would have like closest so far or something like that, and we can initialize it with infinity so that we can always get the closest one, and then we will compare using the because the problem says the closest to target in absolute difference, and so we'll compare using the absolute difference between the previous target and the new target, right? And that's we will then try for equal to 1, and then at that point nothing is smaller than 1, so still our I equal to 0, and still our left sum is equal to 0, and our right sum is all 1s, so it's 1 multiplied by for all the values that are not bigger than 1, or the values that are bigger than 1, and so that would be basically length of array minus I again. And so it would be just length of the array, right? And so we will closest so far would now be equal to 1, and then we'll try 2. Now when we try 2, it becomes interesting because 1 is less than 2, right? So we advance our I value, and then our left sum would become the value 1, right? And then our right sum now is everything except the first value, so it's these values here, and so it's 2 multiplied by length of the array minus I, which pretty much gives us length of the array is 1, 2, 3, 4, 5, 6. So it gives us 6 minus 1, so it gives us 2, so it gives us 10, right? So we have 10. So now closest so far, because target is equal to 15, so the value for target I'm considering is 15, right? So we compare, well, 15 minus 1 is equal to 14, and 15 minus 10 is equal to 5, so this one is better, and so we set closest so far to be equal to 10, right? And then we try 3. Now 3 also is interesting because 3 is smaller than 1, and 1 and 2 are smaller than 3. So that would mean we would advance I by 2. So I was 1, because right now since array I is smaller than t equal to 2, we know that since the array is sorted, it's by definition smaller than t equal to 3. So we don't have to go back and count all those that were found in the previous t values, and that's where the optimization comes from. And so now we can just say I plus 1. So we start from I equal to 1 and start from this left sum. We don't need to recalculate it, because since it's smaller than t equal to 2, it's necessarily smaller than t equal to 3 because the array is sorted. So now our I is equal to 0, 1. So we advance. So now our I is equal to 2, right? So now our I is equal to 2, and our left sum is equal to 3. And our right sum would be essentially the value of t, so 3 multiplied by length of the array minus I, right? That's all the values that are left, because that would mean basically that we will keep 1, 2, and then replace everything else. So we'll replace 4 here, we'll replace it with 3, 5 replaced with 3, 9 will replaced with 3. So that's why we are doing 3 multiplied by all the rest. This is length of the array and this is I. And so we say length of the array, this is I here, length of the array minus I, that's the number of 3s we have. And so that's 3 multiplied by, so length of the array we said is 6 minus 2, that's 4, and that gives us 12. And so again, we compare 12 minus 15, that's 15 minus 12, that's 3, 15 minus 10, that's 5, this one is better. So again, we get closest so far to become 12. And of course, when we find closest so far, we need to update the current value. So here the current value is 2, here the current value is here the current value is 3, here the current value is 2. And in this example, we could go I could go and try t equal to 4, but this is the answer. T equal to 4 will not give us a better answer. But yeah, so this is essentially the idea is, let's try the values from 0 to all the way to the maximum of the array. And to avoid doing this time here, we are going to keep track of left sum, because since we sorted the array, we won't need to calculate the left sum again, because when we are here and we already know left sum is this, and we are trying a new t value, we would know that all the values that we already put in left sum are smaller than this current t value, right? And so we'll just keep increasing I and keep increasing left sum, right? And so let's see how would that look like in terms of code. So in terms of code, we would have to do, so let's define our function was find best value with where we'd had array and target. So first we need to sort the array. So we take the array, we sort it, right? Then we need to have both closest so far, right? Closest so far and the value that it represents, and then we initialize that to infinity, so float maybe inf in Python, and then the values will start out as 0. And then we need left sum, since we keep track of it and it doesn't change while looping because we sort the array, so we initialize it outside of the array. And now we can go through the array here. We can go through the possible values using from 0 to max array, as we said. So for t in range of from 0 to the max array value, and in Python to get that value we say +1. From here, what we can do is, well, all the values smaller than the target value, those are left sum, right? So we will need to put these there. So we need also our I index, since our I index doesn't get initialized with each I value, as you can see here, because we know that we already put these values in left sum. And so what we do here is we said while, of course, we have still elements in the array. So while I is less than the length of the array, and of course the array value is less than t, right? Because if it's bigger, we need to replace it. So if that's the case, then we need to add it to the left sum, right? And we need to advance our I pointer. Now we have the left sum. Now we need to calculate the right sum, which we said is just the target value multiplied by the length of the array minus I. And so the sum, the current sum that we are trying is left sum plus right sum, which is t, multiplied by length of the array minus I, right? And so this will give us the and so now that we have the entire sum, we need to check if it's better than the closest so far. So we say if, in terms of absolute difference, of course, so if the left sum so we say if left sum is if left sum minus target, sorry, not left sum, if this current target minus current sum, so target minus s is, of course, we want the closest, right? So we try to see if it's less than what we had before, which is target minus closest so far. So if that's the case, that means that we find a new beta value. So we say closest so far is equal to S, and then value is equal to T, right? And then we, at the end, we return value. So we could see here, while going through T, we didn't reinitialize I, and we didn't reinitialize left sum. We kept accumulating into left sum so that we don't go and repeat, and so that makes it that we go through the array only once. So it's O of n actually, and then we go through all of the T values, and so it's kind of O of n plus T instead of multiplied by. Yeah, so that's pretty much it. So sorting it allows us to do this accumulation here without needing to initialize the array. That's the main insight. The rest is just trying all the T values and seeing which one is closest to target. Yeah, so right now we will put this in Leetcode and see if it passes. Okay, so I typed the solution that we just went over. So array sorting, and then first, after that, we go through all the possible values for value, and then we add to left sum, and then we compare against target, and we pick the best one. And we accumulate left sum and keep increasing I, and we never reinitialize them because that's the optimization we are doing, and because the array is sorted, it works out. So now let's run this and submit. And let's submit. Okay, so this passes test cases. Okay, so the other way we can solve this problem is using binary search, because we can find a specific property of binary search, that is, when we find usually is we can solve a problem using binary search. So let's go over this one. So basically, with binary search, we need to find a pattern where we can, so that we can have a predicate. So that is the normal binary search, of course, where you need to just find a value at a specific, if the value is in the array or not. But the more generalized version is we need to find a predicate or some kind of test function that allows us to kind of have a pattern where that predicate will give us value while we are searching in the range of binary search, which is low to high. Using, of course, mid value here, we find that the condition, if we pick some mid value, it's false, then it's false. It keeps false in the range, but once it reaches a solution, and when you keep going to the right, it's always true, right? The condition becomes true, and when it becomes true, it keeps being true. It never goes back to false like this. And of course, it can be the other way around. It's not limited to false then true. It can be also like true, 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 false, false, false. But the essential idea is once it becomes false, it never becomes true again, right? And we are looking either for the first true value, first true thing, or the first false value. And so if we can formulate our problem in terms of finding the first false value or the last false value or the first true value, then we can solve the problem in binary search. And so that's what I'm going to try to do here with this problem. And so one thing we can do is define some function. So if I define f of x as the sum, so I'm going to define f of x as the sum of all the values in the array that are less than x, otherwise I just pick x, right? So this is exactly what the problem says. It's basically find all the values that are bigger than, so here we can say bigger than some specific value, replace them with that value, right? So that's exactly what I'm doing here, and this is for a in array, right? So this would be my function. So and this is what I'm looking for. I'm looking to find the the sum using this here, using some specific value x, that I want to find this x here, such that f of x minus target, in terms, of course, of absolute value, is as small as possible, right? That's what I'm looking for. And so here, if I find that f of x is bigger than target, so if I find that f of x is bigger than target, then if I increase x, then f of x will be bigger, will only increase, right? Because I will be replacing with increasing value, so it will only increase, right? And so that would mean here that what I would have is, so the absolute value, the thing I'm looking for is the absolute value of target minus f of x, or f of x minus target, so it's target minus f of x. And so my function here would be that I would have something like, okay, this is not the closest possible, this is not the closest possible, this is not the closest possible, this is not like, and then I would have true, f of x would be bigger than target, and from there it will keep being bigger than target, right? So here, f of x is not bigger than target, right? But once it becomes bigger than target, it will keep being bigger than target, right? So, and what I'm looking for is just finding these two here and picking the smallest of the two, right? Because the solution is either smaller than target but very close to it, or bigger than target but very close to it. It's only these two boundaries. The boundary is close to f of x equal to target, right? So here, this portion here would be f of x less than or equal to target, and this portion here would be f of x bigger than target, right? So now I have my binary search pattern, and I just need to find what is the range that I will be searching on, right? So here, remember, I'm doing f of x, so my variable here is x, which is the possible value that I'm looking for. And so x can be from 0 to target, or from 0 to max array. It can be more than that. So I could try from 0 to target, because, well, I can also try max array, because if I take max array as my value, the array will stay the same. If I take something bigger, that's not useful, because the array will still stay the same, right? So this is the range of my binary search, and that's all I need for binary search. I need to find my function that will tell me to go left or right, and then I will need to find the range that I will need to go in, right? And so that's pretty much it. So the only thing is, when do I go left and when do I go right? So if I find that my f of x is less than or equal to target, right? So if I go to the left, I won't find anything better, because it would be only smaller than target than the previous value. So this would mean I would have to go right to find a better solution. So this means go right, which basically means low equal to mid plus 1, which that's what go right is. Otherwise, if it's bigger than target, that means that if I go more right, I will only find bigger values, so the difference will always be bigger, and so I shouldn't go right, I should go left, right? And so here I go left, and that would mean high equal to mid minus 1. And here, since I don't know, like, maybe the closest value is the one here, or maybe here, so it's kind of slightly different. I'm not looking for the last false or the last true, but I'm looking to the smallest value between the two. So that would mean here I will need to compare and see which one is smaller, right? And so that's what I'm going to do here with my binary search. So let's just write it in full here. So it would be def find best value. We'd have the array and target, and we'd have our binary search, right? So here we need to, of course, I suppose that I already defined the fx function. I already defined it here. And so my low and high values would be 0 in target, as I said, I can also say this is max array, and then normal binary search, low less than or equal to high. I compute the mid. Mid is low plus high divided by 2, using this so that we can avoid overflow. And then the sum would be f of mid, right? Because mid is representing the values of x that we are looking for. And then I need to have a res value that kind of stores the closest sum so far. And then I would need to have the value itself that I will return. And I will initialize both to, I would initialize this one to infinity and this one to 0, right? So I would say if s is less than target, as we said earlier, that would mean I need to go right? So I need to go right, which means I need to say low equal to mid plus 1. And since, as I said, I don't know which one is the solution, whether it's the last false or the first true, so that would mean I would need to say res is, I would just check if the absolute value of target minus res minus s is better than the previous value, so it's less than the absolute value for target minus the previous value, which is res. Then I would assign res to be s, and I would assign value to be mid, right? Otherwise, well, I need to go, as we said here, I need to go left, and so that would mean we would do high equal to mid minus 1. And we will do also the same thing. So we'll just take this here and put it here. So we'll do the same thing because we don't know if it's the last false or the first true. And then at the end, once we are done, we will just return the value we got, right, from the two solutions, from the smallest one we found, and that's pretty much it. Yeah, so that's it for this solution. Let's code it up and see if it passes test cases. Okay, so here is the code for the binary search solution that we went over. So this is the f of x function, which just computes the sum starting from the first value and then keeps going to, and then replaces the values that are bigger than x. And then here we have we have our normal binary search thing, and then here is the function that we said is if f of x is less than or equal to target, we need to go to the right, otherwise we need to go to the left. And we keep updating because we don't know if the best solution is the smallest, is the last false or the last true, as we said in the overview. And at the end we return the best value we found. And that's pretty much it. And you can see here, this is O of log n, such that O of log n is O of log of target, because that's the range we are looking in. And then every time we compute the sum, which is O of n, and so it's O of n multiplied by log of target, which is still reasonable. We are not using any extra space, just these values, so that's fine. So let's submit this. Okay, so this passes all test cases. Yeah, so that's it for this problem. Thanks for watching and see you next time.